The thing making your house feel hot in summer may not be a weak air conditioner. It may be a hidden heater sitting right above your ceiling, your attic. Picture a normal summer afternoon in America. Outside, the sun is beating down on the roof. Inside, you lower the thermostat again. The AC kicks on. Cold air comes through the vents. But the upstairs bedroom still feels heavy. The hallway still feels warm. By evening, the room where you are supposed to sleep feels like it has been holding heat all day. So you blame the AC. You think it is too old, too small, or ready to be replaced. But before you spend thousands of dollars on a bigger machine, look up. Your roof has been absorbing sunlight for hours. The shingles get hot. The wood deck beneath them gets hot. The air inside the attic gets hot. Then that stored heat slowly pushes downward through the ceiling into the rooms below. Your AC is not just cooling your living space. It is fighting a heat bank trapped above your head. That is why a small $4 attic device matters. It is not a miracle. It will not erase every cooling cost. But when used correctly, a simple thermostatic switch can help attic ventilation respond at the right time, so trapped heat has a better chance to leave before your AC has to fight it all night. So ask yourself this: if your AC is running, but your upstairs still feels hot, are you cooling the room, or are you paying to fight the heat trapped above it? But before we talk about that $4 device, you need to understand one mistake that makes many attic cooling fixes fail from the start. Most homeowners think attic ventilation means one simple thing: add a fan and push the hot air out. That sounds logical, but in building science, airflow does not work that way. A fan without a balanced air path is not a solution. It can become a new problem. Here is what is really happening above your ceiling. All afternoon sunlight hits your roof. The roofing material absorbs that solar energy and turns it into heat. The roof deck warms up. The rafters warm up. The air trapped inside the attic warms up. Then that heat begins moving downward. Some of it radiates from the hot roof deck. Some of it conducts through wood framing. Some of it pushes slowly through the ceiling assembly. By the time your AC turns on, it is not just cooling the air inside your rooms. It is removing heat that the roof has been collecting for hours. That is why the path of air matters. Hot air wants to rise, but it still needs a way out. Cooler replacement air needs a way in. In a properly vented attic, air usually enters low through soffit vents under the eaves. Then the heated air exits high through a ridge vent, gable vent, roof vent, or cupola. This is the simple idea behind the stack effect. Warm air rises. But the system only works when the attic can breathe from both ends. Now think about what happens in many real homes. The soffit vents are covered by old insulation. Dust blocks the screen. A bird nest sits behind the opening. Paint seals part of the vent. Storage boxes are pushed against the gable wall. Suddenly, the attic still has vents, but the air path is weak. Then someone installs a strong attic fan and thinks the problem is solved. But if that fan cannot pull enough air from the soffits, it may start pulling air from the house below through ceiling gaps, recessed lights, attic hatches, or duct leaks. That means the cold air you already paid for can be dragged into the attic and blown outside. At that point, you are not saving energy. You are paying to exhaust your own comfort. This is where the $4 device becomes useful, but only when the basics are right. The device is a thermostatic switch. Its job is not to cool the house by itself. Its job is to tell a small DC fan, solar-assisted fan, or attic ventilation booster when to turn on. When the attic reaches a set temperature, the switch closes the circuit. The fan runs. When the attic cools, the switch turns it off. That makes the system respond to actual heat instead of running randomly or sitting idle when the attic is baking. But remember this: the question is not, do I need another fan? The real question is, does hot air have a way out, and does fresh air have a way in? Once you understand that attic cooling stops looking like a gadget problem, it becomes an airflow problem. And airflow must be guided, not guessed. The fastest way to know whether your attic is working with you or against you is not to buy anything yet. It is to run one small test inside your own home. Before you buy anything, test the house. Not with expensive equipment, not with a contractor, just with a digital thermometer, a flashlight, a dust mask if you need one, and a little caution. Choose a hot afternoon, preferably after the roof has been under direct sun for several hours. First, check the outdoor temperature in the shade. Do not measure in direct sunlight because that number will be misleading. Second, check the temperature in the hottest room of your house, usually an upstairs bedroom hallway or room farthest from the AC supply. Third, if you can access the attic safely, measure the attic temperature near the upper part of the space where hot air collects. But safety comes first. Do not step on drywall. Do not enter the attic if the heat feels dangerous. Do not touch wiring. Do not cut into the roof. Do not change any structural part of the house. If the attic is hard to access, unstable, or extremely hot, stop. This test is only useful if it is done safely. Now look around. Can you see daylight near the soffit vents, or is insulation blocking the edges? Are the gable vents open, or are they covered with dustboard, paint storage boxes, or old screens? Is the attic hatch loose or unsealed? Is a bathroom fan dumping damp air into the attic instead of sending it outside? Do you see water stains, mold-like discoloration, animal droppings, damaged wires, or wet insulation? Those signs matter more than any gadget. Now compare the numbers. If the outdoor shade temperature is 95 degrees, but the attic is far hotter and stays hot after sunset, your attic is acting like a heat bank. If the upstairs room stays warm while the AC runs, that trapped heat may be part of the reason. But if the vents are blocked, do not assume a stronger fan is the first answer. A fan cannot move air through a path that does not exist. The first fix is often simpler. Restore the roof's breathing path, clear the intake, open the exhaust, and make sure the attic can move air before you ask a device to do more work. You cannot fix a system you have never measured. So here is the real question. How much hotter is your attic than the air outside? Once you see that number, the $4 device starts to make sense, but it only works when it is placed inside a system that can actually breathe. It is called a thermostatic switch. Think of it as a simple temperature gate. When the attic gets hotter than the set point, the switch closes the circuit and allows a small fan to run. When the attic cools back down, the switch opens the circuit and the fan stops. That means the fan is not running all day for no reason. It only helps when the attic has reached the temperature where trapped heat starts becoming a real burden on the house. Used with the right small DC fan and the right power source, this can help pull hot air out during the hottest part of the day. But this is where we need to be honest. The switch does not cool the whole house by itself. It does not replace insulation. It does not fix leaky ducts. It does not stop afternoon sun from blasting through west-facing windows. It does not solve mold if water is leaking somewhere. And it does not guarantee a lower bill for every home. Your result depends on your climate, roof, design, insulation level, air sealing, HVAC system, duct condition, and whether the attic already has a real intake and exhaust path. This $4 device can make the system smarter. But if your attic has no breathing path, you are just putting a brain inside a body with no lungs. So start safely. Check vents for visible blockage if you can do that without touching electrical wiring or structural parts. Use proper baffles to keep soffit airflow open. Weather strip the attic hatch so cooled indoor air does not leak upward. Make sure bathroom fans vent outdoors, not into the attic. And if you see damaged wiring, water stains, heavy mold-like growth, wet insulation, animal activity, or structural problems, stop and call a qualified professional. This is not a gadget trick. It is system thinking. The device only works when the house is ready to let heat leave. So if the idea is simple, cheap, and based on real physics, why are many modern homes not designed to use it from the start? So why don't builders use this more often? Not because the physics is fake, not because attic airflow does not matter. The real answer is simpler. Builders are not always rewarded for better building science. They are rewarded for homes that sell fast. Most buyers walk through a house and look at the kitchen, the flooring, the paint color, the countertops, and the number of bedrooms. Almost nobody climbs into the attic with a flashlight and asks, does this roof have a proper air path? So the details that reduce cooling load often become invisible details, and invisible details are easy to ignore. That $4 thermostatic switch is not glamorous. It does not sell a house like a new kitchen. It does not look impressive in a listing photo. It is just a small part of a system that needs to be understood correctly. If the soffits are blocked, if the exhaust vents are weak, if the attic hatch leaks, the device cannot rescue the whole house. That is the bigger lesson. Comfort does not begin at the thermostat. It begins with how your house handles heat before the AC turns on. So comment your attic temperature on the hottest day or type attic if you want a safe attic checklist before summer. And subscribe for more practical building science that helps you live more comfortably without wasting money. Before you pay for a bigger machine, check whether your house is holding heat where it should be breathing it out. Sometimes the smartest way to save energy is not buying more power. It is giving heat a safe way to leave.